and why it basically affects how we feel when we use digital stuff. Nowadays, we used to getting very quick answers from our gadgets, our phones, our laptops. So, but if things are like slow, it can really bug us. And in a recent study, big companies like Google and Amazon did some research, and it shows how much latency matters. Further reducing tokenization overhead. So it is basically removing everything that is unnecessary and just passing what the LLM needs to generate the output and a good output. Then we have load balancing scalability. So implementing efficient load balancing mechanism and ensuring your LLM deployment can scale horizontally. So when demand increases, can help maintain low response time during peak usage. Assalamu alaikum everyone. So today we are going to learn about latency in LLMs. It's a very important topic. When you are working with LLMs, you have to take care of latency and you should know how to solve it. So let's get started. Here's the outline, and before we dive in, just make sure you are familiar with some basic LLM concepts. And our objective today is basically understanding what is latency and why it basically matters, and the strategies to basically mitigate and make it improve latency as well. So let's dive into the introduction. So LLMs have basically revolutionized the field of artificial intelligence, showcasing the remarkable capabilities in language understanding and generating human-like text across diverse applications. However, as we leverage LLMs for increasingly complex tasks, we encounter a significant challenge, which is latency. So latency, in simpler words, is like a waiting period when you use a computer program. It's the time it takes for the computer program to process your request and give you a response. So imagine you are having a conversation with someone and they pause for a moment before replying. So that's a bit like what latency is in the world of computers. And when you type a question or a message to a smart computer, it needs some time to think and understand your outputs and generate a meaningful response. So this delay from the moment you send your message to when you get the program answer is what we call latency. And for example, think about a computer program that helps you with questions like chatbot for service like ChatGPT. If it takes even a short time to reply, it can basically annoyed, and you will get basically annoyed and not enjoy using it. So this presentation is basically delve into the importance of latency in the context of LLMs, exploring its implication on user experience and strategies to mitigate it. So latency is a big deal, and why it basically affects how we feel when we use digital stuff. Nowadays, we used to getting very quick answers from our gadgets, our phones, our laptops. So, but if things are like slow, it can really bug us. And in a recent study, big companies like Google and Amazon did some research, and it shows how much latency matters. Just a tiny delay of zero point 0.5 seconds in showing search results on Google made 20% fewer people use it. Similarly, with Amazon, Amazon found that if their website are slow by just zero point 0.1 seconds, which is literally 100 milliseconds, they lost 1% of their sales. So latency isn't just a fancy word, it's a real thing that affects how much money a company makes as well. Now, with LLMs like ChatGPT being used in so many places, the need for low latency is even more critical. Think about autonomous vehicles, and also LLMs are being integrated into security system as well for threat analysis and response. So reducing latency become very even more critical in cybersecurity, because in quick detection and response to basically threats are very important. So they use LLMs for quick decision making. And if there is a lag in processing data, it could lead to accidents. So low processing and low latency is a must for making sure our AI future technologies work safely and smoothly. So when we are talking about what makes requests slow? So there are two main things come into play: the computer model and the number of tokens used. When we are understanding the concept, understanding these factors help us figure out why some requests take long time and how we can make them faster in the world of technology. And making things quicker and more efficient is always our goal. So these requests taking we are talking about, they happen when you ask an LLM like ChatGPT to do something like write a paragraph or solve a problem. Now let's dig into how these requests take time. So it's like it's kind of following a recipe to bake a cake. You have got several steps. So first you ask the LLM for something like, hey, write a paragraph about space. So then there's this powerful server. It's like chef in the kitchen. It starts figuring out what you want, like understanding what you're asking about space. Next, it gets to work. It starts creating the text you asked for, just like the chef starts baking the cake. And to figure out how long this process basically takes, you add up the time the server spent understanding your request and the time it took to create the text for your output. So the total time is called latency, and it's basically how long you had to wait for the answer. To get a sense of where it's fast or slow, you don't just do it once. You have to repeat these steps several times and find the average time. That's how we figure out if our requests are speedily or if they need some improvement. So, talking about some important factors. What really important when we are dealing with how fast or slow these computers program work, it boils down to two main things: the computer model itself and how many building blocks of text called token it uses. Understanding these factors, like knowing the essential of a task, and if you know what influences the speed of a computer program, you can make it work better. So, understanding about tokens and their impact. Now, let's talk about tokens in specific transformers. We have talked about transformers, and we all know about what tokens are. So, token are just like pieces of a puzzle. The more pieces you have, the longer it takes to complete the puzzle, right? Similarly, more tokens means more work for the computer, which slows things down. So, if you're trying to speed up things, you need to pay attention to tokens. It's like making sure you have just the right amount of resources for a task, not too much, not too little, just the right amount. And then basically making things faster. So how do we make these computer programs faster? Well, we have got some strategies here. We will talk about in detail in the next slides. But first, we can use some smaller computer models. Think of them as smaller or faster cars. They might not have all the advanced features of a larger model, but they can get you where you want to go more quickly. Then you can do some other things like simultaneously, like handling multiple tasks at once. In computer terms, this is called parallelizing token generation. So it's like having more workers on a project, getting things getting done faster. And guess what? We can also reuse some of the things we have already created. It's like having a toolbox full of ready to use tools. So this is called caching frequently generated tokens. And it is a very smart way to speed up things. So by considering these aspects, and we will talk about this in the next slide in detail, and using these strategies, we can basically make these computer program faster and provide you with a smoother and quicker experience. Just like understanding the essential factors in a task, these details helps us deliver results in a very better format. Uh, Now, talking about some techniques that we follow in while doing mitigating these latency problems and issues. So talking about that, the first one is prompt optimization. So as established earlier, longer prompts require more tokens, leading to increased latency. So one strategy is to carefully design prompt that convey the desired information concisely. Then prompt structure. So structuring prompts efficiently can also reduce token count. For instance, instead of using a lengthy descriptive sentence, sentence or use bullet points or keywords can convey the same information with fewer tokens. Then model selection. So smaller models with fewer layers and parameters tend to have low latency. While they may not match the performance of larger models, they can be sufficient for many tasks and significantly reduce the response time as well. Then we have hardware optimization. So GPUs are generally faster than CPUs for deep learning tasks, and optimizing GPU usage and selecting the right GPU hardware can help decrease the processing time. And then specialized hardware for organization with the resources, specialized hardware like TPUs, tensor processing units, can further accelerate LLM operation and reducing latency eventually. Batch processing, we have batch size and batch parallelism. So batch size, adjusting the batch size can impact latency. Like large batch sizes can improve overall throughput, but might increase individual request latency. So smaller batch size can be faster for individual request. And model batch parallelism, parallelizing token generation across multiple instances can basically significantly reduce latency, especially for handling multiple concurrent requests. Then caching, we have talked about this earlier as well. So caching frequently generated tokens can be a highly effective thing if your application frequently generates similar responses, or if they are common text fragments that appear in multiple requests. Caching can save significant processing time. Then pre-processing. In like we have two things here: subword tokenization and input formatting. So utilizing subword tokenization techniques such as byte pair encoding, BPE, or word piece can simply the like they can basically simplify the input text and reduce the time required for tokenization. Then input formatting. So pre-processing can include removing unnecessary formatting or structures text to make it more machine readable, further reducing tokenization overhead. So it is basically removing everything that is unnecessary and just passing what the LLM needs to generate the output and a good output. Then we have load balancing scalability. So implementing efficient load balancing mechanism and ensuring your LLM deployment can scale horizontally. When demand increases, can help maintain low response time during peak usage. So it is very helpful as well. Then network optimization. So ensuring that your LLM deployment has optimized network configuration can minimize data transfer latency between user request and the LLM server. Then we have parallelism concurrency. So leveraging multi-thread and asynchronous programming can enable parallel processing of multiple requests, reducing the wait time for users. Quality versus speed trade-off. So depending on the specific application, you might need to make trade-offs between model quality and speed. So essential to strike a balance that align with your user expectation. Then monitoring and profiling. So regularly monitor and profile your LLM system to identify bottlenecks and areas where latency can be optimized further. So tools like profiling software and performance monitoring can basically provide valuable insights. Then in the last we have incremental updates. So if your LLM is basically fine-tuned or updated periodically, consider using incremental updates and instead of retraining the entire model. So this can reduce the downtime associated with the model updates. So reducing latency in LLMs is an ongoing process still that requires a combination of thoughtful design, hardware selections, software optimization. Specific strategies that you employ will depend on your application requirement and resources available. But a systematic approach to latency reduction can greatly enhance the user experience in LLM powered systems. Now talking about talking about some very common strategies that we face nowadays is like a combination of different things. So optimizing prompt size without compromising accuracy. So striking the right balance between prompt length and accuracy is very crucial. So while shorter prompts reduce the number of tokens and speed up response time, they must still convey the necessary information for accurate outputs. Carefully crafting of prompts to be concise and informative is very essential, because that is the whole point, that your accuracy should be good and acceptable. And if you're decreasing the basically prompt length, so you're basically minimizing your requirement as well. So striking the balance is very essential. Then we have balance, latency reduction, and maintaining model performance. So latency reduction should not come at the expense of model performance. So while minimizing processing time is very important, it's equally important to ensure that the quality of responses remain very high. So this is a complex trade-off that requires continuous fine-tuning. Then we have batch size caching and pre-processing. So several techniques can influence latency. Adjusting batch sizes, for instance, can impact the rate at which requests are processed. So implementing caching mechanism for frequently generated responses can reduce the need for recomputation, leading to faster responses. So additionally, pre-processing data, such as eliminating irrelevant information that we talked earlier, or formatting input more efficiently, can reduce tokenization time. We have talked about this earlier as well. And smaller models and hardware choices. So the choice of model size and hardware can have a very significant impact on latency. And smaller models may inherently process token faster than larger ones, but might sacrifice some aspects of performance. And hardware choices, like using GPUs or TPUs designed for a parallel processing, can accelerate token generation, helping reduce uh, basically response time. So we will discuss this in the next slides, like in the next lectures as well, that how cost influence LLMs, how all of these combined basically make a difference with latency as well. So uh, wrapping up, in conclusion, the realm of LLMs is marked by both groundbreaking advancement and persistent challenges. So latency, as one of these challenges, demands our attention and innovative solutions. So by understanding its implication and exploring strategies for mitigation and striking a balance between speed and model performance, we can navigate the intricate landscape of LLMs more effectively, and ultimately bringing us closer to their full potential in various applications. So it's very important. And that's all from my side. Thank you so much.